Hello guys, so today we will be talking about expectations value. Now, we know that we can write this equation for any particle with energy E. And from this equation, we find out many solutions for the behavior of this particle, that will be psi. And then for the other properties, we operate on psi with other operators. For example, to find out the momentum, we will operate with p cap, that is the momentum operator on psi, and then get its value. But last time we saw that it does not give p psi type of solution to this equation. That means psi does not always follow the eigenfunction for other equations. So psi can be eigenfunction for this equation but cannot be for other equations. And then we use psi as a combination of more than one wave functions. Each of these wave functions will be eigenfunctions for the next equation. In this case, we can write psi as C1 psi1 plus C2 psi2. And then we will obtain P1 C1 psi1 plus P2 C2 psi2. The P1 and P2 values are the momentum values that the particle will have. So suppose you perform an experiment on the particle and try to measure its values. You will get only these two values. That is, sometimes it will be P1 and sometimes it will be P2. You can also find a probability or the number of times you will get P1 and the number of times you will get P2 as your answer. That means you can calculate how many times the momentum of the particle will be P1 and how many times the momentum of the particle will be P2. Let's see how we do that. Here is a general equation of psi, and obviously if psi is written as a combination of more than one values, then it will be something like this. For simplicity, we are taking only two terms, but there can be more. Now, we will multiply each of these equations with psi star. That is the conjugate of our wave function. And then we will integrate each side from minus infinity to positive infinity. So let's solve the right hand side value and you will obtain omega 1 C1 psi1 plus omega 2 C2 psi2 multiplied by C1 psi1 star plus C2 psi2 star. Here I am using the property of imaginary numbers. And moving on, you will have minus infinity to positive infinity, and multiplying all these terms you will get four types of terms, and hence we will integrate each term separately. These four terms are now taking the constants outside, you will be left with now look closely. These equations and this equation, you are multiplying, you are basically taking the square of psi over the whole space, and we know that these wave functions are normalized, and so these two will have the value 1. On the other hand, these two wave functions are orthogonal to each other as they are the product of the same equation, and so that equation is p cap psi, and so these two wave functions will be orthogonal, and the whole summation or the integration, you would say, will be 0. So these terms will be cancelled and these terms will only be 1. We are left with only these two terms. For a normal equation such as this, which follows an eigen equation, you would have obtained omega psi. And if we had performed this maneuver that we just did now on this type of equation, if omega cap psi was a normal wave function, normal eigen equation, and we would have obtained omega psi, and we had done what we have done earlier and multiply each of the side by the conjugate of psi, and then integrated both the left hand side and the right hand side from minus infinity to positive infinity, you can see that this value again will be 1 only, and hence we will obtain the observable omega. So in this case you will get only one value of omega, and that will be the value of omega that you will always obtain in every experiment. But it is not so in the above case. If the psi that we just talked about is a combination of more than one wave functions, then you obtain a value like this, and this is called the expectation value. It is called the expectation value, and it is denoted by this. We had only two terms in the above assumption. We can also have more terms as the function becomes complex. Now, here each term is an observable value that you will get. C1 square or C2 square, C3 square are the probabilities as the number of times you will get these values. So for example, you perform your experiment 100 times, then C1 square times you will get omega 1 value, C2 square times you will get omega 2 value, and C3 square times you will get omega 3 value, and so on. So there will be just as many number of values you will get terms there are. And of course C1 square plus C2 square plus C3 square and so on will be equal to 1 only. So these are basically the fractions. So in the momentum problem above, the expectation value of momentum was P1 C1 square plus P2 C2 square. So now you know how to find the expectation value of any equation. Here is a question for you. So suppose the momentum, or let's say the wave function, is A sine kx. Find out the expectation value of momentum. Answer in the comments below. Thank you so much.